Good day, friends. Welcome to the Cybersecurity Foundational class. And in this class, we will continue with topic 4, which is the operating system. And we're going to treat several topics under the operating system. One of it is the computer build process. Second is the types of operating systems. Then we have the functions of an operating system. And then we have how an operating system is built, and we move to CLI versus GUI operating systems. I'll wrap up this session with the operating system file system management. Computer boot process and types of operating system. So we're going to talk about the computer boot process. What happens in the background when you turn on your computer? The first thing first, when you want to turn on your computer, is to press the power button, and electricity from the power supply wakes up the computer. So the CPU starts first, and the CPU is the first component which starts working. And um, at that stage, the CPU does not have any instruction yet. So what does the CPU do? The CPU now looks for those instructions from your BIOS. So when we talk about BIOS, what is BIOS? BIOS is basic input output system, and BIOS is a small program stored on the motherboard of your computer. So this BIOS tells the CPU what to do first. And then we have the CMOS and the CMOS battery. CMOS, that's the CMOS. So CMOS is a tiny memory chip that stores information or stores important settings in your computer. So we're talking about the time, the boot order, and the likes. And this CMOS comes with a battery that keeps those settings saved. Even if when your computer is down or your computer is off, it has its own dedicated battery that keeps those settings safe. Your time, your boot order, and the likes. So the BIOS now reads these settings from your CMOS to know how to start the computer. Not only that, your BIOS also have other activities it run. One of the activity is the power on self test. So that's what they call the post. So your BIOS check if your RAM is working fine, if your CPU is okay, if your keyboard and other components of your computer is doing very fine. So if there's any issue, if there's any issue that is suspected or that is noticed by your BIOS, there will be a beep from your computer. So anytime you turn on your computer and you notice that you hear a beep during the booting process, means that the BIOS has raised maybe an issue that it discovered from the hardware of your computer. So what happens next? Your BIOS then uses the CMOS settings to find where the operating system is stored. Usually your operating system is stored on your hard drive, either your hard disk drive or your solid state drive. And then the computer reads the first important file from that drive. So from your drive, the computer then reads those important file. The process of reading those important file is called bootloader. Now these files start loading the operating system. So for the BIOS goes through using your CMOS settings to find the operating system, and then what happens during that process? Your computer then reads the first important file from your drive, and this file that is being read starts loading your operating system. And then the next is that your operating system is now copied from your hard drive into your RAM, because your RAM is much more faster. I gave an analogy about the use of RAM. It's a temporal place whereby program is being stored to run, and that process of storing your program on your RAM helps your RAM your program to be faster in execution. So that is what happens here. So your OS then, in the process of loading your system, your OS is being copied from your hard drive into your RAM to make it much faster. And what happens is the OS then loads your drives, your services, and finally shows your login screen. So if I were to say this in summary, I would say that the booting process goes this way. First, you power up your system, then the next is your CPU gets instruction from your BIOS, and also your BIOS gets some certain read some certain settings from your CMOS, and also during that process, also run the post operations that is checking the your BIOS also check the hardware components of your computer to see if they are good or they are working properly. And the next is that your BIOS finds your OS on your hard drive, checks for your OS on your hard drive, and then load that OS. And in the process of loading it, it copies the OS also to the RAM, and your OS start loading all the drives, your services, and every other component, software component of your computer, and get your computer ready. So, in summary, you can say this process is called bootstrap. So, when you hear bootstrap is not the HTML, CSS framework. Is bootstrap of a computer is the process at which your computer boot from the start to the finish. What happened in the background is what they call the bootstrap. So, just to reiterate, an operating system is the main software that controls the computer. So, it's an instruction given to your computer to carry out a particular task. So, it manages the hardware. The operating system manages the hardware. It runs the programs and also allows you to interact with computer with the computer itself. So the types of operating system that we have the Windows, we have Mac OS, Linux, Android, and so on. So this brings us to the types of operating system. So we have varieties types of operating system, starting with batch operating system. So in batch operating system, the system collects tasks and process them one after another without user interaction. So in the this batch operating system existed in the olden days where we have limited input device. So we don't have keyboard, we don't have a mouse. So we only have what they call the punch card. So what you just do, you just itemize your tasks and load it to your computer via a punch card, and your computer from there, start executing. So that is what batch operating system is, but it's no longer in use. What we are currently using is the next type of operating system, which is the time sharing operating system. So this time sharing operating system, many users can work on the computer at the same time, sharing the same CPU. So the type of time sharing operating system is the one we know, the Linux, Mac, Windows, and so on. So the next type of operating system is the distributed operating system. So this is where several computers work together and appear like one single system to the user. So we have that kind of operating system. And an example of this kind of operating system is the Amoeba operating system, the Locust, and the likes. Then the next we have is the network operating system. Now, when you talk about network operating system, it's actually designed to manage networked computers. So when you talk about networked computers, that means computers that are connected to each other. So which in that process of connecting to each other, they share files, they share the same printer, they communicate and so on. So an example of a network operating system is the Windows Server. And lastly, we have the real-time operating system. So in this type of real-time operating system, the major um, application, or let's say the major devices that uses the real-time operating system are the smart watches, the smart TV, the ATM machines, the digital camera, and so on. So these are the types of operating system. So when you hear outside, what are the type of operating system, you can just list one, two, three of it or four, and you can now buttress more on the time sharing operating system, since that is what we are very used to. That's the Linux, Mac, Windows, etc. So we have the functions of an operating system and how an operating system is built. So we're going to look at the function one after the other. The first function of an operating system is that it manages hardware. We've said this several times. So your OS is the one that controls all hardware parts of your computer. So we're talking about the CPU, your RAM, your keyboard, mouse, speaker, printer, and so on. So your OS makes sure that they work properly and they talk to each other. The second thing your OS does is to manage your memory. So when I talk about managing your memory, we're talking about your RAM. So the OS decide which program uses your RAM, as which application uses your RAM, how much RAM each program gets. So how many gig of RAM does your program get, when to remove those programs from your RAM. So your OS also controls when or how to remove your application from the RAM, from using the RAM's resource. So this keeps the computer fast and prevent it from crashing. So your operating system have so many um, important duty to ensure that it manages your RAM. The next thing is that it manages your process. So your OS manages how your program or your application runs. It controls all programs that runs on your system. Your operating system controls all programs that runs on your system. So it decide which program runs first, which runs next, and make sure that multiple programs can run at the same time. Your operating system ensures that multiple programs can run at the same time without any problem. So also your operating system manages file and storage. So your operating system organizes file and your folders, also ensure that it is well saved on your storage device, like your hard drive, your SSD, and it also allows user to create, open, save, delete, rename files easily. This is the work of your operating system. Also, your operating system provides user interface. So your operating system provides a way whereby the users can actually interact with the computer. So this can be through graphic interface, that's using the icons, your windows, your mouse, and your mouse cursor and the likes, or the command line interface by typing commands. So the next thing your operating system does is that it manages devices, both the input and output. So it controls both your input device, your keyboard, your mouse, your microphones, which are the input device of your computer, and also your operating system controls the output device, your monitor, your printer, your speaker. So even as an ethical hacker, if you are going to ethical hacking, one of the major things they target is they can get access or gain control over your operating system, because this operating system is so powerful that once your an hacker have an access to it, it can do anything with your system, both on your hardware and even the application itself. So the next is security and access control. Your operating system actually protects the system or your computer by controlling user access. It's also in charge of users' password, permission, and also prevent unauthorized user from accessing your file and program. So when you talk about unauthorized, when you hear unauthorized means something or somewhere you're not supposed to be, you are there. Something you're not supposed to have, you have it. That is unauthorized. So your OS prevents something like that. So how is your OS built? So we're going to talk about the components of your OS, what your OS entails. So we're talking about the hardware. Your OS needs hardware to operate. Without an hardware, your OS cannot do anything. So your operating system needs an hardware to operate. Your operating system also have what they call the bootloader. So the bootloader is a small startup program that loads the kernel of your operating system into the memory when the system is powered on. During the boot process and your computer boot process, we talked about bootloader, which is part of um, which is part of the component of your OS here. So it's a small startup program that loads the kernel of your operating system into the memory. So what is a kernel? When you hear kernel is a very, very important part of your operating system. So kernel is the core of your operating system. It directly controls the hardware, your CPU time, memory, and devices. That's what your kernel does. It does in fact, the control we'll be talking about is about the operating system is done from the kernel level of your operating system. And then looking at what they communicate with, your kernel communicate with your bootloader, with your driver, your memory, process management, and so on. The next is your the device driver. Also, your OS also have what they call the device driver. So the device driver work is to translate programs. It's a translator of programs, and it allows the kernel to control specific hardware devices. So without your device drivers, your kernel cannot directly control those hardwares, or, those devices. So you need a device driver to allow your kernel, which is a core part of your OS, to control your hard drive, or your hardware per se. So we have memory management. It's still part of your OS. So memory management helps to control how your RAM is shared. Like I said, one of the function of operating system is the management of memory. So the memory management is a core part of your OS. So, and the next we have is the process management also. We also said that your OS is in charge of running programs. So, in terms of how your OS is being built, you can't take away process management. There must be a functionality built, an inbuilt functionality that helps in process management. So, in this case, your OS manages running programs, CPU scheduling and multitasking. Then also we talk about file system. Your OS also, organize helps to organize data into files and folders. So this component too is part of what makes up your OS. Then security and user management is a component that makes up your OS. Your system services and utilities is what the part of the component that makes up your OS. And even your user interface, your OS must have a user interface, whether a graphical user interface or a command line interface. So, you know, if you're looking at the whole thing, how an operating system is built, look at the system services, security, file system, memory management, device drivers, kernel, bootloaders, and also the hardware. CLI versus GUI operating systems. So we want to know the differences. So we're going to take it from the feature standing point. So from the feature point of view, we want to know the difference between a CLI and the graphics, that's GUI, graphics user interface. Now, what is a CLI? A CLI, we're looking at the meaning, is users interacting with the system by typing text command. So when you hear CLI means the process of user interacting with what? The system by typing text commands. And for the GUI, user interacts with system using windows, icon, buttons, and a mouse. So in terms of input method, for a CLI operating system, what you use for your input method is only the keyboard, because you only type. While for GUI, you can use your mouse, you can use your keyboard for search, you can use your touch screen, and so on. Then is it easy? For CLI, it is not that easy. It's harder for beginners and require memorizing commands. While for GUI, it is easy to learn and is user friendly. What about the speed? For CLI, it's very fast. So when you use CLI to operate on your system, it is very, very fast. While for GUI is kind of slow. And then when we talk about resource usage, for CLI, the CLI use very little resource, like very little RAM or CPU, while your graphics user interface uses, much more RAM, much more CPU. Then is it user friendly? It's not user friendly. CLI is not user friendly, to be honest. But GUI, yes, to an extent, very user friendly. Then what about error handling? The truth about the matter is, if you type small mistake, it can cause error when you're using CLI. But GUI, you don't have any per se. You don't really fall into much error because most of the things you do is just to click. When you open your Windows machine now, you see your Word, Microsoft Word, Excel. You can just double click on it, and it opens. But if you want to maybe read a document on your CLI, there's a command you need to type, and you have to spell it correctly with the right capital, either capital letter or small letter. You must use right alphabet, to describe what you want to do or the particular action you want to do. And that's why CLI is error prone, because you're always typing a command. When we start doing practical, you see what I'm talking about. Therefore, automation, it is very easy to run automation using your CLI, but you cannot automate per se using a graphics user interface. You can't automate because you definitely, either you click or you search. You cannot write a command that will just like maybe run a script that will do this task, do this task, do this at the same time. You can do that on your command line interface, but you can't do that on graphics user interface. What about multitasking? CLI is very efficient for multitasking, but you will not see what you're doing. It's not visual appealing. You only see text up all around. You won't see maybe any kind of graphics or the likes. Why GUI, it is very easy to manage multiple apps visually. So you can always click, open, close, open three, four application and close. You can also do that on CLI, but the only thing is that you will not see the visual representation of what you're doing. Also, the command line interface, in terms of security, um, the security on command line interface is very high, and that's why cybersecurity professionals will play a lot on your CLI. That's why you need to learn things like PowerShell, your Linux, for you to be able to operate on your CLI. Why for GUI, less it is there's less security, and is less commonly used by system administrations or administrators. The next is example. So what's an example of a CLI? So we have MS-DOS, we have Linux terminal, we have PowerShell, we have Bash, we have so many of them. While for GUI, we have Windows, we have macOS, we have the graphics user interface for Ubuntu. We also have the CLI interface for Ubuntu. But definitely, we have the Ubuntu desktop and so on. So what is it best for? What is the CLI best for? The CLI is best for advanced users. So if you're an advanced user, you're a cybersecurity professional, you go for your CLI. Always use your CLI, command line interface to do your stuff. It's also good for developers, system administrators, cybersecurity professionals, cybersecurity tags, and so on. Why for GUI is just for beginner, everyday user, office workers and the likes. So this is an example of what we mean about the CLI and the GUI. You can see this is a CLI. This where my red dot is you can see terminal, you can see debug console output. This is an example of a CLI. And you can see the other one which has icon and an image as a background. This is your GUI. Is graphically represented. So you can see your icons here. So this is an example of your GUI and CI. So you're going to, as a cybersecurity professional or an IT professional, you're going to spend much of your time on a CLI environment. OS file system management. So what is OS file system management? A file system management is how the operating system organizes, stores, find, and protect files on a storage device. So the file system management helps the operating system to know where data is stored and how to access it quickly. So that is what the file system management is all about. So when we talk about file, we mentioned file in file system management. We said file system management is how the operating system helps to arrange, keep, search, and also secure our files. So when you talk about files, what does a file mean? A file is a collection of data stored on a computer. A file is a collection of data stored on a computer, and we know what data is. So data can be your age, your name, your height, your um, personal characteristics and the likes. So, and also data can also be measurable. So you can talk about numbers, you can talk about um, symbols, diagram, and the likes. So an example of a file is a document. So when we talk about a document, what data is contained in a document? We can talk about the name, maybe a person's data, the name, the sex, the age, the height, the weight. When you type them in a document and save it, that particular file is known as a document file. So we also have picture, picture of a goat, a cat, a dog, picture of your house, picture of your car, your phone, and the likes. We also talk about video. So video maybe of your naming ceremony, video of a wedding, video of a burial ceremony. So those are types of files. We also talk about programs. So programs are executables. So we're talking about your TikTok, your software applications, your TikTok, your Instagram, your Facebook, and any other application you use, your day-to-day applications you use are also type of file. So what does the operating system does? The operating system helps you to what? Create a file, to open a file, to save changes in that file, and also to delete the file. So it is the operating system that is in charge of this activity. So the next is directories. What is directories? When we talk about directory, when you get directory outside, directories also means folders. So directories is also known as folders. And what is a folder? A folder are used to organize files or subfolders. So a folder can also have a folder. So a folder can be stored in another folder. A file can be stored in a folder. So that folder helps to what? Organize the files or a subfolder. And what does the OS does in this case? What does the OS does? It creates folders, it stores files inside that folders, it allows folders inside folders. That is what the OS does, the operating system does for us. So the folder helps to keep data neat and easy to find. So the next is file name and extension. So file name, the OS helps to manage the file names and also helps to um, assign file extensions to our file name. So when you talk about file name, you can say report.docs. So when you hear report.docs, meaning that name of that file is called report. You can also have report.pdf, or you can even name it like your name, Ife Oluwacv dot docs. That means that particular document is my CV. The name of that document or that file is called Ife Oluwacv. The .docs there is the file extension. So it tells the OS the file type. The file extension is the .docs. So we have .docs, we have .pdf, we have .xlsx, that is for Excel. We have JPEG, that's JPG, that is for pictures, and so on. We have so many file extension. As we progress, we'll see what those we'll come across a lot of file extension and know what they mean. So this file naming, this helps the OS know which program should open the file. So when you name a file and there's an extension to that file, that extension will now determine which program or which application will open the file. So when you see .pdf, meaning is a PDF file, so that means it's a PDF application that will open that file. When you see .docs, DOCX, that means it is a Word document. That means either you use a Microsoft Word to open it, or use your Google, maybe your Google Word, or your Word per se to open it. So if you see PDF, you see JPEG, or you see PNG, which represent picture. If you see PNG or JPEG, that means you have to use a picture. application to open. If you see MP4 represent video, that means you have to use a video application to open it. And if you see .exe too, .exe represent an application, So that is it. Then we have storage management. The OS controls how data is written to and read from storage. So, like we said so many things about operating system. We know that operating system is in charge of data management, it's in charge of storage, and the likes. So the OS decide where files are stored on your disk. The tracks the OS tracks free and use space. Also, the OS helps to prevent data from overlapping. So those are the things that operating system does. It also prevents data loss. So the next is the file access method. So when we talk about the file access method, we're talking about the read, write, execute. So the OS helps to control how files are accessed. So when you see R, when we will get there. So when we're dealing with maybe Linux files, when you see R means that file can be read. W means the file can be edited. You see X means that you can run the file. So the OS controls how programs and users interact with files, and that's what comes to the file access method. The OS is in charge of if you can read the file, if you can edit the file, or if you can view the file, or if you can run the file or the program. The next is permission and security. It's the same thing as the file access method. So the OS protect the file using permissions. So the OS determines if you can read a file, if you can write to a file, or if you can or who can execute a file. So it decides that actually. So the OS prevent unauthorized access or changes. Yes, that's what the OS does. Now, the next is the file system type. So you don't need to cram this, just need to know this. You don't need to, cram anything, just for you to just know the type. So there are different operating system used for different file systems. So when you talk about Windows, we talk about NTFS. So NTFS is for Windows, ext4 is for Linux, FAT2 or FAT32, sorry, for that FAT32 or exFAT is for USB drives. So you don't really need to know, you just need to know the types. When you hear of NTFS, is a type of what file system for Windows, categorically for Windows. When you hear ext4, is a type of file system for Linux. So, and each file system controls how data is stored and managed. We're going to get there where we'll go in details on how it is being done. We have the file operations. So for the file operations, the OS allows common file action. So we're talking about copy, move, rename, delete, search, and so on. So basically, file operations, copy. The OS allow you to copy. You can copy file from one place to another. You can move file from one place to another. You can rename a file. You can delete a file. You can search for a file. It is the operating system that allow you to achieve this. Without an operating system, you can't achieve this in a file system. So the management of a file system, in fact, is done by the operating system. So all these actions are managed safely by the operating system. And lastly, we have the file backup and recovery. So the OS help us to protect our data by supporting backups, recovering deleted files, from recycle bin. So most of us that will delete our file, those files go to the recycle bin. You can go to the recycle bin and restore those files you've deleted. It is the OS that help you to achieve that. Also, the operating system helps you to repair damaged file systems. So by so doing, the operating system is very important in preventing us from permanently losing our data. Still on operating system, file system management, it's just an illustration. So this is typically for example, this is a Linux operating system. So this backslash, don't none of you cramming anything. We will still get to this. The bin temp user, that's USR and ARC. All these are the follow com folders or directories that comes with your Linux. So you don't need to cram it. We'll still go in details, but I just want to illustrate how folder or how file system operate or file system management works. So we have a folder here. In this folder, we have subfolder. So in this slash folder, we have some subfolders, which is the bin, temp, user, and the ARC. In this bin, we have a file inside this bin called the echo. And in this user, that's the USR, we have a file inside it, a folder inside it called John and Mary. In Mary's folder, we have a file called dog.jpg. I know JPG means that this is a picture. And also in this folder, John, we have HW1 folder. And in this HW1 folder, we have main.c. So this is like a C program, yeah, an application itself. And also we have cat.jpg in this John. So this is our file system. So when you create a folder on your system, you create a file, a document. This is how it's being represented. So if you want to represent it in a diagram illustration or a structure, this is how you're going to see it. So this is how it is being arranged in a file system. So and each file has each its permissions. So you will definitely, when you start doing writing some Linux command, and if you're playing with Linux, you will definitely see something like this. Maybe when you're checking the information about the file. So you see this ls-l, you're trying to list the permissions for that particular file. So ls-l, the file name, when you put that in your Linux command, it will give you the list of the file and also the details, so the permission of that file. So you see something like R means that the file is readable. You see W is writable. You see C, that's executable. You see dash, that's denied. So there are a lot of things that definitely when we go in details, you understand how this work. So in summary, we have just more of like an illustration. We have root directory, directory one, directory two, directory three, which is like the subdirectory for the root directory. In the directory two, we have file one, and we also have subdirectory and file 2. Now, in this subdirectory, we have file 3 and file 4. So this is just a simple way of representing our file system management. So I think we've come to the end of lecture 4, and we'll say topic 4. So we'll meet same time. I will upload the next lecture in few hours or few days from now. I will upload the next lecture, which is topic 5. See you in the next class. Thank you, everyone, and please continue to follow, continue to share, like, comment. Thank you all, and God bless you.